Hi everyone of all the Narayana students of 10th standard. Now today I am in front of you all to discuss about a topic, current electricity, and the assignment which is given to you all, which is of 6th assignment. Now when we want to talk about this particular topic, we need to have a good idea about the Ohm's law. V is equals to IR. Right? Let me use little better color, which will be a little clear for you. V is equals to IR. Now, this formula is very important for us, and it is only called as Ohm's law. Now when you want to explain about this is nothing but this law is applicable for all the conductors. When you talk about the conductors over here, I am trying to explain it in the form of graph. Now we have voltage, which is an dependent variable on y-axis, and current, which is an independent variable on x-axis. Now when you check out this graph, you will be having a linear graph. Actually, according to Ohm's law, that means V is directly proportional to I. That means if you check this graph, as you increase your current on x-axis, the same way you are going to get an increase in voltage. That means the graph is going to be linear. So I am directly saying that V is directly proportional to I. That means as you increase your current, the voltage is going to increase in the same way. So that is your Ohm's law. Now we have a formula V is equals to IR, and that Ohm's law is applicable for the option. The question is over here, Ohm's law is applicable to first option, ohmic conductors only. Second option, non-ohmic conductors only. Third option, both ohmic and non-ohmic conductors. Vacuum tubes only. Actually, the word naming itself, you can easily tell that it is only applicable for ohmic conductors. Ohmic conductors are the conductors which give you this exact graph. When you come for non-ohmic conductors, it is applicable, but the graph is not that perfect. So definitely you have a difference in the graph, like you will not get a linear graph. So the option for this question is 1, right? So let us go for next question. Right, the second question which is given to you all, Ohm's law is not applicable for. Very good question. It is like, let us think it is a sequel for the first question. Now it is not applicable for insulators, vacuum tubes, semiconductors. It is only applicable for conductors, as well as it is very perfect in ohmic conductors. So the option over here is all the above. All the above, right? So it is very easy for you. And next question, it's a very theoretical question. So let us go with the next question. The electric intensity E, current density J, and conductivity sigma are related as, okay? We'll call it as rho. Okay, now what we are going to talk about this is the relation between this. If you want to talk about the relation, definitely we will try to explain it. Let us take a conductor whose length is L. We will take a conductor whose length is L. And now let us think, we are providing it, this is a conductor whose length is L, and this conductor's area of cross section, let us take it as A, and let us give it with some potential plus and minus, as soon as you give the potential which is of higher from one side and lower from another side, let us take this as V. Now, as you give the potential difference for this, definitely for this conductor, you will find a electric field created inside this. The electric field which is created inside this is going to be given with E, and it is a vector quantity. It is a vector quantity. And now let us take a small cross sectional area over here. Okay. Now if you take a cross sectional area, the density over here, let us take, we'll talk it as conductivity. Okay. The conductivity we'll take it as. Let us take the conductivity. So here the current density, if you want to judge, like for example the current density is denoted with J. This J is equals to the density at this particular area, the density of the current at this particular area, density of the conductor, density into the electric field. So this is a vector, this is also a vector. So vector into a conductivity is going to give you another vector. Now this is J is equals to current density into electric field. So the first option is correct. So let us go for the next question. Fourth question. When you are talking about this fourth question, the formula V is equals to IR is applicable to. That means where is this formula applicable? V is equals to I into R. So V is equals to I into R is nothing but it is actually applicable for both the ohmic and non-ohmic conductors. You have a spelling mistake over here. This is ohmic. The third option is correct for this. It obeys the V is equals to IR, the Ohm's law, the formula is going to be applicable for both ohmic and non-ohmic conductors. For all the conductors it is applicable, whether it is an ohmic conductor or non-ohmic conductor. The graph might come in different ways, but this formula is exactly applicable for both ohmic and non-ohmic conductors. Next one. Fifth question. The PD, that means the potential difference between the ends of a wire of resistance 5 ohm is 720 coulombs of charge passes through it per minute. Now when you talk about this, the potential difference between the ends of a wire of resistance 5 ohm if 720 coulomb of charge passes through it per minute. So per minute in the sense you are going to have 60 seconds over here, 60 seconds. So let us convert all into SI units. Now SI unit, ohm is the resistance. So here resistance is given as 5 ohms and your density, that is quantity of charges, were given as 720. Okay. Now next the time is given as 60 seconds. Now if we try to apply this Ohm's law, let us try to apply V is equals to IR. If you try to apply this formula, now I is nothing but, formula for I is Q, that is the quantity amount of charges per unit time. So charge per unit time, so Q by T into R. So V is equals to Q by T into R. Now what do you say about this Q? Q is nothing but the amount of charges which are present. Now what is the amount of charge which is present over here? It is 720 coulombs. 720 coulombs. Now if you want to tell about this, 720 into resistance, how much is the resistance given to you all? Resistance is given as resistance is 5 ohms by the time is 60 seconds. 60 seconds. So let us talk about this. So finally you will be getting 60 volts as your answer, right? So your answer is third option. Your answer is third option. Done. So next question. Ohm's law is valid when the temperature of conductor is. This is a very direct and straightforward question. Temperature should be constant whenever Ohm's law should be agreeable in any conductor. It might be ohmic or non-ohmic, whatever it is. Most probably ohmic conductor. If you need ohmic conductor, if you need the conductivity to be if you need the Ohm's law to be fixed, that means the Ohm's law should be obeyed. If the Ohm's law should be obeyed, the temperature should be definitely constant. Then only it is going to validate the Ohm's law, or else it is going to be a difference, and you will you can't let the Ohm's law going to be fixed. You can't expect the Ohm's law to be fixed, right? So now the answer is constant, right? Okay, I hope this will help you out. Bye.